Welcome back to Impact Analysis. Each week, we break down a real-world risk that leaders need to understand, not just what's happening, but what it could mean for operations, infrastructure, and the continuity of modern life. My name is Jerome Ryan. I'm joined by my co-host, Mike Janko. Mike, what's our topic for today?
I'm really glad to join everyone here today. Let's shift from geopolitical to something that's less visible, yet could be more systemic. We're talking about the sun. Specifically solar flares and coronal mass ejections, or CMEs, and what they can mean for our global infrastructure.
Okay, heavy topic here. So the last major event around a coronal mass ejection, a CME, was the Carrington event in 1859. None of us remember that because none of us were alive back then. But the Carrington event was the most intense geomagnetic storm in recorded history. It happened in the very first parts of September 1st through the 2nd of 1859. And to ground us in this type of event, if a similar event hit the Earth today, obviously we are a much more advanced society with our microprocessors and digitization of everything. But if something happened like this today, our power lines, our utility infrastructure would be impacted, pipelines, undersea cables, any of our space assets, GPS, radio, cell phones, all of this across networks and communications would be impacted. It's not going to look like those big budget doom movies from Hollywood, but it would propagate through with interruptions. And I can also add that, governments are watching this. They do consider this a long tail event, a black swan or a gray rhino, if you will. But, this is something that could potentially happen and could cause chaos. We're going to talk about what this is, how it could impact us and what you can do about it. So let's go ahead and jump in, Mike. Go ahead.
Great. Thanks, Jerome. Solar cycle 25. Is what's happening right now. It's stronger than it's initially predicted. Let's go over the basics of flares here. So there's 3 different classifications of solar flares. The most basic one is low is level C. Then you have a level M class, which is 10 times the severity of a C. And over that, you have a level X, which is 10 times the level of an M. So thousands of minor or C-class solar flares occur every year. Hundreds of the M-class occur every year when there's peak activity. And during active years, there's 20 to 40 major X-class flares. So these are the ones that are most intense, the solar explosions. They can disrupt GPS, as you said, satellites and radio communications. In 2024 alone, there were dozens of these X-class flares, several that triggered strong geomagnetic storm watches globally. But flares are only part of the story.
Yeah, and I think, again, recognizing this is a bit of a heavier topic and something that's a little bit more long-tail risk, think back to the pandemic. Prior to the 2020 global pandemic, we had massive global pandemics before, but it had been since 1918. And so people forget that throughout the 100 years in between the 2 major global pandemics, we'd have small ones, regionally located. And I think we need to think about CME in that same light, where, they do happen quite frequently, but they're on a very small scale. But a large one could happen and will happen at some point in the future and impact sort of modern day, how we interact with each other and how life is today.
So as you said, Jerome, this is a global risk, as the pandemic was, and it escalated pretty quickly. And this is not a U.S. problem, it's global. Regions at higher geomagnetic latitude include Canada, Northern Europe, the UK, Scandinavia, and Northern Asia. So they're actually more vulnerable to the geomagnetic induced currents than much of the continental U.S. In 1989, there was a geomagnetic storm that collapsed Quebec's power grid in under 90 seconds. And as you said earlier, these are novel things. These are things we don't always think about. But today, the interconnected grid is a lot more complex than in the past.
Looking at sort of the infrastructure that we have today, I mean, we've got many thousands of satellites in orbit. Be 9,000 active satellites, probably not including Elon Musk's Starlink, which I have no idea how many he has up there in the sky right now. But we have 9,000 active satellites in orbit, more than 7,000 in sort of that low Earth orbit distance, and certainly thousands more planned going forward. So that solar flare, that solar storm impacts all of those. And again, the knock-on effect is how we are able to communicate or not, here on Earth.
Let's talk about GPS and the timing risk. So everyone's aware of what GPS is, but maybe not aware of how it transcends into being used in other activities throughout the world. So it's not just navigation. It provides timing signals and it synchronizes a lot of banking transactions, the stock exchange, all our cellular networks, power grids. We brought up power grids earlier, aviation rerouting when you're traveling, shipping logistics. So there's 4 global satellite navigation systems in operation. In the US, we have GPS. In Europe, Galileo. Russia has what's called the GLONASS. And in China, they have the Beidou. So they're all vulnerable to this disturbance with geomagnetic storms. GPS timing degrades, you risk financial transaction errors, telecom instability, and a big impact on your power grids.
Yeah, and in addition to the power grid and the satellites that we've talked about already, there's more than 10,000 data centers worldwide. And again, that number is growing as well. And you've got a number of these hyperscalers focused in those same types of geographies across North America, Western Europe, China, India, and even in Southeast Asia. So, when the power grid and grid stability gets impacted, these data centers get impacted. It disrupts those daily life things that you've just talked about, from banking to communications to dive deep here into supply chain again. But all of that gets impacted if GPS, data centers, and communications are impacted.
And specifically to power grids, their impact, Jerome, the highest risk is the high voltage transformers. And there's roughly about 2,000 critical large transformers in North America. And there's thousands more across Europe and Asia. And all of these large transformers, they can weigh up to 400 tons. It takes up to 2 years to manufacture a new one. They're custom engineered and they rely on these international supply chains, which we've spoken of, which are extremely complex. So if multiple ones of these transformers fail across continents, the replacement of them, it's going to be a huge global bottleneck. It's going to affect supply chain. It's going to be a major power crisis.
Yeah, I think you brought up a really interesting point there. I was at a global energy conference in New York City last year, and we were talking about gas turbines, one of the speakers. And there's a 6-year wait list to get a new gas-fired turbine, manufactured and delivered. So when an event happens, it's not just going down to the store and buying a replacement item. Like you've mentioned here with the transformers, there could be a 1 to 2 year or more, right? If we have a major CME event, everybody's going to be trying to replace these. There could be a very long multi-year wait to have those transformers manufactured and installed. So I think the point here is that these magnetic storms just don't affect one sector, right? We're talking about communications, data centers, satellites, banking. It really cascades throughout, all those different sectors and the components of those sectors that help, modern life continue.
When we're talking logistics and transportation, just to conclude on that, Jerome, when things are clicking well, it's complicated enough. If we have this type of issue occur, we're going to have GPS for rerouting. Ports are not going to be automated. Our just-in-time inventory management is not going to be effective. So without everything being synchronized, timing, and good communications, everything's going to slow down. Cargo, shipping, rail scheduling, everything depends on this digital coordination, and it's extremely fragile if it's not working well.
Why don't we transition a little bit about what leaders should be doing now, right? Because again, this is kind of a heavy topic. It's a long tail risk. What should we be doing now as executives and leaders?
As you said, Jerome, this is a novel risk like COVID, like war, things that we didn't think of that could be occurring. So a couple of things to consider. First, map the infrastructure dependency past your IT systems. This is going to affect everything that we do. Don't just think IT. Think about what kind of exposure you may have to satellite dependent services. When we test scenarios, typically through a walkthrough, a tabletop, any kind of exercise, you typically do it over the course of a short time duration. You need to take a look at outage scenarios that are weeks, not just hours, for an extended period of time being without a critical process. What are you going to do? Talk to your utility companies and telecom providers about geomagnetic preparedness. It's a new topic. Let's start those discussions now. Take a look at your backup fuel logistics and resilience to make sure that if there's something that's really critical to maintain your operations, you're staged and ready to go with it.
The number one takeaway that I have to share is, solar storms are real. They are reoccurring. They're not theoretical. They happen, as you mentioned at the top of the video, with some, level of frequency. But look beyond solar storms and look at all of your long tail risks and review those long tail risks periodically. It will actually help you in understanding your overall company risk and how you approach it in different areas.
I think the next item, Jerome, number 2, would be with over 9,000 satellites, all the 4 big global GPS systems, and I think we said over 10,000 data centers exposure. This is unprecedented. The way we do everything could potentially be affected.
And number 3, I would say, is it's really a global infrastructure risk. Again, looking a little bit at the 2020 pandemic and how it impacted, all sectors and all countries globally. An event like this could do the same thing. So it's not just the United States or Europe or any one geographic area that will be impacted. It's going to, impact everybody, and we're all interconnected these days.
And maybe a fourth one to look at, Jerome, would be the interdependencies and cascading system failures. It's not just a single item that's going to be affected. It's going to cascade into everything that we're using to be productive, to maintain our business. So think about that. If you think that it's limited, it's not.
Good point. Well, in closing, a Carrington style or scale event, could happen today. It's not an IT incident. It would be a global infrastructure, communications stress to modern life. So it's something that you should put on your long tail risk analysis. And we thank you again for joining Impact Analysis, and we look forward to seeing you in our next video.
Thank you, everyone.